All right, so this section that we're going to cover deals with compound inequalities. So what a compound inequality is is basically two inequalities in one. There are two different ways that they distinct them, and one is joined by the word and, one is joined by the word or. How you're going to see it is and is all written as one inequality with whatever the variable would be in between two different inequalities, whereas ors would be already separated by the word or. And when you graph them, they will go away from each other, and ands will go toward each other but won't pass. So they'll be connected by that inequality line. I like to think of the oars as going away. Kind of looks like a boat. Like if you were rowing a boat, the oars are going away from you. That's how I remember them. So if I see an or problem, typically they're going to be going away from each other. Really what we're going to do is if we have an or problem, we just graph each one, but the and we have to read, and we can separate it as two different ones, so we can think of this as -2 is less than or equal to x, or x is greater than or equal to -2, and then you could also think of it like this. This is the second part, x is less than 6. So when we do, or we solve for compound inequalities, the or problems, they're already separated, we just solve for each, which would be this example. But for the and problems, we have to do a little bit of legwork. We have to write out two separate inequalities and then solve for each. So similar to what I just pointed out here, where we have the blue part and the red part, you're going to write two separate ones for these examples. So -4 is less than r minus 5, so we write that out as 1. And then the other one would be r minus 5 is less than or equal to -1. And then what we do is we just solve each one of these and then graph them on the same number line. So you would add 5 to both sides. That would give us 1 is less than r. Here we would add 5 to both sides. This would be r is less than or equal to 4. And then you would graph them on the same number line. I always put 0, 1, and 4, so we have 1 here, 4 to the right of 1. This would be a closed circle. This would be an open circle. And I read it backwards, right? R is greater than 1. R is less than or equal to 4. So less than or equal to 4, greater than 1, they're going that way. And we just connect them in the middle. So that would be the graph of an and inequality. So these examples we're just practicing, writing them twice, solving, and then doing the actual graph. So if we look at this problem, we can start by writing my first problem as -3 less than 2x minus 1, and I'm going to stop there because then the 2x minus 1 is less than 7 is going to be my second problem. And then we solve for each of these. When you write out the and problem, it's kind of nice because it's the same two steps. You know, sometimes you're starting on the left or right, but it's the same two steps to solve for the problem. So I would add 1 to both sides. This would be -2 is less than 2x. Divide by -2, or divide by +2, sorry. And then we have -1 is less than x. So there's one of my answers. All right, over here I'm going to do the same two steps. Add 1. 2x less than 8. Divide by 2. X is less than 8 divided by 2 would be 4. All right, so there's my two inequalities. Now I just have to graph them on a number line. I'm going to put 0 in the middle. -1 goes to the left. 4 is to the right of 0. Open circle at -1. Open circle at 4. And then x is less than 4, so that's going this way. X is greater than -1, so that's going this way. So they meet in the middle. So that would be our graph of that inequality. All right, over here. You can pause this and then try this one. But I'm going to start by writing out my two inequalities. 7 is less than -3n plus 1. So I can stop there. Stop when you get to that second inequality. So there's one of my problems that I'm going to do. And then over here, I'm going to start with the middle part. -3n plus 1 less than or equal to 13. All right, and then you do your steps to solve for that variable. Subtract 1 from both sides. 6 is less than negative 3n. Divide by negative 3, both sides. Since I divide by a negative, I flip the sign. Subtract 1. Negative 3n less than or equal to 12. Divide by negative 3. And flip the sign because we divide by a negative. Negative 4. Then we can draw our number line. Label 0. Negative 2. Negative 4 to the left of that. Close circle there. Open circle there. N is less than negative 2. N is greater than 4, so they meet in the middle. Alright, for the OR problems, they're already separated for us. So we just go ahead and solve each of these and then graph. So minus 7 from both sides. Negative 2x greater than negative 4. Divide by negative 2. So x, flip the sign, because we divide by a negative. Negative 4 divided by negative 2 is 2. Now we do this one. I'll do this one in blue, or I'll do this one in black. So add 4 to both sides. So 3x greater than or equal to 9. Divide by 3. X is greater than or equal to 3. Now we have to graph these on the number line. So I'm going to put my 0 just to indicate my middle. 2 and 3. So 2 would be here. 3 would be to the right of that. Again, I'm not worried about tick marks, just in where they are in relation to each other. Open circle at 2. Close circle at 3. In their OR, so they should be going away from each other, but let's just check. So x is less than 2. Less than 2 is going to be indicated this way. X is greater than 3, indicated that way. So for these compound inequalities, you're going to eventually end up graphing them all. So it's just solving basically for 2 inequalities within each problem. But just with the ands, we have to make sure we separate the 2 first, whereas the ORs are already separated for us.